Hello friends, welcome to Learner's Planet. Friends, this is our second session for zeros of polynomials. In the previous session, we discussed the zeros, the coefficient of various types of polynomials, maybe linear, quadratic, cubic and biquadratic. And we also found the relationship among coefficients and zeros of polynomials, right? So in this session we'll be taking problems based on the various concepts which we have discussed so far, maybe types of polynomial, degree of polynomial, relationship between zeros and coefficients, and more than that, right? So do attend the previous sessions before you come for this session, and let's begin this session now. Now friends, let's take multiple choice questions, and first we take some basic question based on various terminologies and definitions included in the chapter polynomial. Now, which one is not a polynomial, that we have to find out. Now, what is the basic definition of polynomial? That the variable should be having integral power, that's positive integral power, right? So just see where we do not see the positive integral power, that's in this option. Here the power of x is -2. So this expression is not the polynomial, right? Similarly, here we can see x is having -3 power, that means x, this is further power which is not positive integer. So this is also not a polynomial. So A and C, both of them are not polynomial. So answer here it will be D, where both A and C are not polynomials, right? Now polynomials having two terms only are known as binomials, as simple as that. Degree of polynomial px is equal to 5, right? And how do we determine the degree? That is the degree of the variable. So we can write it's 5x raised to 0, because x raised to 0 will be 1, so it will be 5 into 1, that's 5, right? So what is the degree of the polynomial is determined by what is the degree of the variable. So degree of the variable, that is power of the variable, over here is 0. So the degree of the polynomial is 0, right? Now a polynomial of the form 5 3x square has at most. In the previous session itself we have discussed that whatever is the highest power of the variable, this is the number of 0, that is at most number of zeros. So this polynomial is a fifth degree polynomial, so we'll get at most 5 zeros, right? Not more than that. Okay. Now friends, let's see this question. If in applying the quadratic formula to a quadratic equation fx is equal to ax square plus bx plus c0, it happens that c is equal to b square by 4a, then the graph of y is equal to fx will certainly. First of all, we know that if it is a quadratic polynomial, the graph observed over here will be a parabola, and if a is positive, the graph will be an upward parabola, that is opening upwards, right? Now what is a quadratic formula? I just write over here. If we wish to find out the roots of a quadratic polynomial, the formula for the same is minus b plus minus b square minus 4ac by 2a, where b is what? Coefficient of x, a is what? Coefficient of x square, and c is the constant term. Now this is what the quadratic formula, right? By which we can find out the solution or zeros of a quadratic polynomial. We just put the value of a, b, c over here, and you'll be getting the values of zeros of the polynomial, right? One value will get by plus sign and one value will get by the minus sign, right? So this is what the formula to find out the zeros of a quadratic polynomial. Now if b square minus 4ac is 0, b square minus 4ac is 0, that means b square is equal to 4ac. That means what? There is no point of putting plus and minus over here. In that case we'll be getting 0 over here, so plus and minus will not produce two different results. So in that case both the zeros will be equal, that is minus b by 2a. Getting my point? So if both the zeros are equal, the parabola will touch x-axis or it will be a tangent having parallel to the x-axis, right? We already discussed the graph of the same, that is something like this. Okay, I just redraw it once again. Right? So in this case, both the solutions or both the zeros are same, right? Or we can say we can have a tangent parallel to x-axis, right? If suppose instead of x square we have x minus 2 whole square, then we'll be getting a tangent parallel to the x-axis, right? So whenever both the zeros are equal, we will be getting tangent that's parallel to x-axis. Okay, so I hope you are clear. Now the next question is the number of points of intersection of the polynomial x cube plus 8 with x-axis is. Now friends, it's a cubic equation, so at most it will have 3 points of intersection. So what I do is I equate it to 0. So x cube plus 8 equal to 0. That means x cube is equal to minus 2 whole cube. That means all the three values of will be same over here, that is minus 2, minus 2, minus 2. That means the curve will not intersect the x-axis at three different points, but it will touch x-axis, right? Since we are having a single zero for this polynomial, that's minus 2 only, right? So the curve will just intersect at one point, okay? Because all the three values are same. Now we have done this question. Now if a is less than 0, that means the coefficient of x square is negative. Ax square plus bx plus c, the graph of this. Now we have already discussed the graph will be a parabola. It's maybe opening upwards, maybe opening downwards, right? Now if the coefficient of x square is negative, then we get a parabola that is opening downwards, right? So it's ax square plus bx plus c. If a is less than 0, we'll be getting a parabola opening downwards like this, right? These two are wrong, and this is for when a is greater than 0, right? In this case, this is wrong because in this case, two values of x we are getting. That means y is, for two values of y, x is 0, which is not possible. So these two are wrong options. Okay. Now next is every quadratic polynomial can have at the most. Quadratic polynomial, that means second degree polynomial, that means maximum two zeros are possible, that we have already discussed, right? Now the next is a cubic polynomial can have at most three zeros, that we know, right? Degree of polynomial, this is, if I just simplify it, I'll be getting x raised to 3 minus 2 plus 7. That's x plus 7, right? So what will be the degree? That's 1 only, right? Now ax cube plus bx square plus cx plus d is equal to is said to be a cubic polynomial. If, see, if it has to be a cubic polynomial, we should be having this term, right? And this term is possible only when a is not equal to 0, right? Now we see sum of the zeros of the given quadratic polynomial is. Now how do we calculate that? Sum of the zeros is what? Alpha plus beta, right? And alpha plus beta is what? Minus b by a. If we make the comparison with ax square plus bx plus c is equal to 0. So b is what? Coefficient of x, and here coefficient of x is what? That's 0, right? So minus 3x square plus k is equal to 0. In this polynomial, sum of the zeros will be nothing but 0, right? Because we do not have the coefficient of x other than 0. Okay, so it's 0. Similarly, if a and b are the roots of quadratic equation, this with the condition a minus b is equal to 1, then the value of b is, right? Now let's calculate that. If a and b are roots of this or zeros of this polynomial, then we can say, suppose a plus b are the roots. So sum of the roots will be coefficient of x in negative, by coefficient of x square. So a plus b is what? It's minus b, right? AB is what? That's product of the roots will be what? The constant term, that's 12, and a minus b, we know that's 1. That's given to us, right? Now if we simplify this equation, we'll be getting the value of a and b both as well. I just can guess, since 4 into 3 is 12 and 4 minus 3 is equal to 1, that means value of a and b will be 4 and 3, right? So I just put the value of a and b over here. So p will be minus 7 or 7. So we get the value of p as minus 7 or 7. And how do we get 7? If we have the values of a and b as minus 4 and minus 3, then also the product will be 12, and minus 3 minus minus 4, that will also be 1, right? So we have the values of p as 7 or minus 7, right? Now let's take this question. If one zero of the polynomial is reciprocal of the other, then we have to find out the value of k. Now if one zero is alpha, other will be what? 1 by alpha, right? That means if we multiply them, that is alpha into 1 by alpha, will be getting 1, right? That means product of the roots is actually what? That is what? The constant term by the coefficient of x square. So here it will be 4k by k square plus 4, right? So that's actually 1, because alpha into 1 by alpha, one root is alpha and other root is 1 by alpha, and their product is 1. So that's actually constant term. So that's c by a, that means it's 4k by k square plus 4 is equal to 1. Now we can solve this equation by cross multiplying. So k square plus 4 is equal to 4k. That means k square minus 4k plus 4 is equal to 0. So that means k minus 2 whole square is 0. That means k is equal to 2, right? I hope you are clear. It's very simple problem. Now this question, if alpha beta be two zeros of the quadratic polynomial, then we have to evaluate the value of this. Now we have already discussed alpha plus beta is what? That is coefficient of x by coefficient of x square in negative. So it's minus 5 by 3. Now alpha beta is what? That's constant term by coefficient of x square, that's 13 by 3, right? So if you make the comparison by ax square plus bx plus c, then alpha plus beta is what? Minus b by a, and alpha beta is equal to c by a. That you just remember. So every time you do not have to recall sum of roots and product of the roots, right? So alpha plus beta is minus 5 by 3 and alpha beta is 13 by 3, right? Now we have to calculate the value of this expression. I just take up LCM. So it will be beta plus alpha over alpha beta. Now what beta plus alpha? That's same as alpha plus beta. So that's minus 5 by 3. Divide by alpha beta. So if I put a multiple sign, I just reverse that. So it's minus 5 by 13. Right? Now suppose this is the polynomial with us and we have to find out the value of alpha square plus beta square. Now alpha square plus beta square, how do we calculate? See here, first of all I just write alpha plus beta is what? It's minus b by a, and alpha beta is what? C by a, that's 13 by 3, right? Now if I write alpha plus beta whole square, what I'll be getting? Alpha square plus beta square plus 2 alpha beta, right? Now I put the value of alpha plus beta and alpha beta over here. Now alpha plus beta is minus 5 by 3. So square of minus 5 by 3 will be 25 by 9. That's alpha square plus beta square, because I don't know the value, or we have to find out the value of the same, plus 2 alpha beta, that is 2 into 13 by 3, that is 26 by 3. So alpha square plus beta square is equal to 25 by 9 minus 26 by 3. right? So that's the value we can calculate. So the value will be in negative. So 25 minus 78, it's minus 53 by 9. That's the value of alpha square plus b square, as simple as that. Okay. So this is how we can calculate the value of alpha square plus beta square. Precisely, alpha square plus beta square is alpha plus beta whole square minus 2 alpha beta, right? I just write it over here. Alpha square plus beta square is alpha plus beta whole square minus 2 alpha beta. This relationship will be used various times. This is nothing new. I just have reshuffled or rearranged the alpha plus beta square is equal to alpha square plus beta square plus 2 alpha beta expression, right? So I hope you are clear now. Now friends, this question, the same quadratic polynomial we are having, now we have to find out the value of alpha by beta plus beta by alpha. So suppose I take LCM, I'll be getting alpha square plus beta square by alpha beta. Now we just have calculated the value of alpha square plus beta square as minus 53 by 9, right? So I just put the value of alpha square plus beta square. So that's minus 53 by 9. By alpha beta is what? 13 by 3. So I divide this by 13 by 3. So what I'll be getting? 3 by 13. So it's 3. So it's minus 53 by 39. Right? I hope you are getting me. Now for the same equation, we have to find out the value of alpha cube plus beta cube. Now we can factorize alpha cube plus beta cube. So that's alpha plus beta, alpha square plus beta square minus alpha beta, right? Now we can directly put the value of given expressions. We know what alpha plus beta is. It's minus 5 by 3. We have already calculated that. Alpha square plus beta square we have calculated as minus 53 by 9. Right? Here we have calculated. So I just put the value of alpha square plus beta square directly. Minus 53 by 9 plus it's minus, and alpha beta is what? It's 13 by 3. So this is minus actually. So now I just have to solve it. So it's minus 5 by 3. It's minus 53 by 9 and it will be minus 39 by 9. So minus 53 minus 39 by 9. Right? So it's the total minus will be plus. So 5 into 9 plus 3, 12. 5 and 3, 8 and 1, 9 by 9. Right? So this is what the value of this expression. So 5 into 2, it's 460 by 9 into 3, I'm sorry, it's 3 over here. So it's 27. So it's 460 by 27. Okay, quite an interesting problem. Similarly, we can calculate the value of this expression. I take LCM, so I'll be getting alpha cube plus beta cube by alpha beta. Now alpha cube plus beta cube, I have just calculated that 460 by 27. Right? I just put the value directly. You don't have to put, you have to solve it in your exam. I just put it over here. 460 by 27 divided by alpha beta. Alpha beta is what? 13 by 3. So it's 460 by 27 into 3 by 13. Right? So it's 460 by 13 nines are 117. Okay. Now similarly, in this question, alpha beta are the roots of this equation. We have to find out the value of this expression. Now what will be value of alpha plus beta over here? It's minus b by a. So it's minus of minus 7 by 4. That's 7 by 4. And alpha beta is what? 3 by 4. Right? Now we have to calculate the value of this. So first of all, I just take LCM. So I'll be getting alpha square plus beta square by alpha beta. Now how could I calculate the value of alpha square plus beta square? That is alpha plus beta whole square minus 2 alpha beta, and this is alpha beta. Now we just have to put the values of the given expressions, and we can get the answer, right? Now alpha plus beta whole square will be 7 by 4 whole square, that's 49 by 16, minus 2 alpha beta, that's 2 into 3 by 4, so precisely it is 3 by 2, by alpha beta is what? 3 by 4, right? I just solve it. It's 49 minus 24 by 16 into 4 by 3, right? Now what is 49 by 24? It's 25, right over here. 25 by 16 into 4 by 3. So it's 25 by 12, right? As simple as that. I hope you are getting me now. Now in this question, 1 upon alpha plus 1 upon beta we have to calculate. If I take LCM, I'll be getting alpha plus beta by alpha beta, right? Now what will be the value of alpha plus beta from here? It's minus b by a if I make comparison from ax square plus bx plus c. So coefficient of x by coefficient of x square in negative. So it's minus b by a, so it's minus 1, and alpha beta is what? Product of the roots, that is the constant term, right? So alpha beta is 1. I just put the value over here, so it's minus 1 by 1, precisely it is minus 1, right? Over here also similarly we can calculate. The same expression is there. Alpha plus beta by alpha beta we have to calculate. Alpha plus beta is what? Minus b by a, that's minus 3 by 4, and alpha beta is what? 7 by 4, right? Just put the value, minus 3 by 4 into 4 by 7, so it's minus 3 by 7, right? Now the sum of reciprocals of the roots of equation is this. Now what is roots? I assume to be alpha beta. What is their reciprocal? There are 1 upon alpha and 1 upon beta. Now sum we have to find out, that means we have to find out 1 upon alpha plus 1 upon beta. So this is other way of asking the same question, but the value which we have to calculate is the similar as the previous one. Now alpha plus beta is what? Coefficient of x by coefficient of x square in negative, so it will be, I just write over here, it's minus b, and alpha beta is q. So the value of this will be minus p by q. As simple as that. Okay. Now friends, in this case we have to find out difference of roots. That means we have to suppose the roots are alpha and beta, then we have to find out alpha minus beta, right? Now what's alpha plus beta over here? It's minus 4 by 4 minus, right? So it's 1 only, that's minus b by a, and alpha beta is what? That's c by a, that's 1 by 4, right? Now what's alpha minus beta whole square? That's alpha square plus beta square minus 2 alpha beta. And what's alpha plus beta whole square is alpha square plus beta square plus 2 alpha beta, right? Now I just put the value of alpha plus beta over here and alpha beta over here, and I'll be getting the value of alpha square plus beta square, right? So I just put, it's 1 is equal to alpha square plus beta square plus 2 times 1 by 4, so it's 1 by 2, right? So alpha square plus beta square will be half, right? Now I put the value of alpha square plus beta square over here, and I'll be getting the value of alpha minus beta whole square. So from here, alpha minus beta whole square is alpha square plus beta square, so it's 1 by 2 minus 2 into alpha beta is what? It's 1 by 4, right? So it's half minus half, that's 0. That means alpha minus beta whole square is 0. That means alpha minus beta is 0, right? That means the difference of the roots is 0. I hope you are getting me now. Now similarly we can try this question. Alpha beta be the zeros, so alpha plus beta is what? It's minus 5 by 2, and alpha beta is what? 1 by 2. right? We have to find out the value of this expression. Put the value of alpha plus beta, and alpha beta, it's minus 5 by 2 plus 1 by 2, that's minus 4 by 2, that's minus 2, right? Now in this case, alpha beta be zeros of the quadratic polynomial this, then alpha plus beta is what? Now friends, this is a parabola opening downwards because coefficient of x square is in negative. So I just rewrite this equation, minus x square minus 3x plus 2. So alpha plus beta is what? Minus b by a. So minus of minus b is what? I'm sorry, minus I have written b is what? 3 by 1. So it's minus 3, right? So that we don't have in the option, so it will be none of these. Okay? I just redo it, I'm sorry. I written it minus x square minus 3x plus 2. So alpha plus beta, I just take this. I just show you how to make the comparison. Ax square plus bx plus c, and sum of the roots is minus b by a, right? So a is what? Minus 1, b is what? Minus 3, right? So alpha plus beta is, I take this minus s common, put the value of b, it's minus 3, put the value of a as minus 1, so it's minus of 3, right? So that's none of these, right? Now in this question, alpha and beta are zeros. So first of all, I just simplify it. It's x square minus px minus p minus c, right? And we have to calculate the value of alpha plus 1 into beta plus 1. So that will be alpha plus beta. It's plus alpha beta plus 1, right? So we have to get the value of this. So from here, alpha plus beta is what? It's p. Alpha beta is what? The constant term, that's minus of p plus c, right? So I just put the value over here. Alpha plus beta is p, then it's minus p minus c plus 1, right? So it's minus c plus 1, or I can say 1 minus c, right? Now in this question, similarly, alpha beta are zeros, and we are given that alpha plus 1 into beta plus 1 is 0. That means alpha beta plus beta plus 1 is equal to 0. Now according to us, alpha plus beta is what? It's, I just rewrite it, x square minus px minus p minus c. So alpha plus beta is what? P, and alpha beta is minus of p plus c, right? Now I put the value over here. So it's minus of p minus of c plus p plus 1, and that's 0, right? So we have to get the value of c. So minus c is equal to minus 1, that means c is equal to 1, right? I hope you are enjoying the session. It's pretty simple once you are clear with the concept of zeros. Now friends, we'll be taking more problems in the next session. Do revise this session and the previous sessions as well. Bye bye.